Hey everyone, welcome back to my YouTube channel. If you are new here, make sure to hit that like button and subscribe for awesome coding tutorials, data science projects and real world problem solving videos every day. Today we are solving a classic coding interview question. Move all zeros to the end of an array in place. Okay, so it might sound easy, but here is a catch. You can't use extra space and you need to minimize the number of operations. So let's break it down. Here is the problem. We have been given an array and that contains some integers. And we have to move all the zeros to the end of the array. That means in this array we have two zeros and 1, 3, 12 as non-zero numbers. So 1, 3, 12 will remain in their original order and all the zeros will be pushed to the end of the array. So, and we have to do this in place. Okay. So let's think smart. We want to minimize operations and avoid using extra memory. What if we treat this like a two-pointer problem? One pointer, last non-zero, it keeps track of where the next non-zero element should go. And the second pointer, I, loops through the array. So whenever we see a non-zero element, we swap it with the element at last non-zero element. So let's code this. So we will define a pointer last non underscore 0 equal to 0, and for I in range, here I is the I in range. Here I is the new pointer that will move through the array and it will be in the range of length of nums and then if nums of I is not equal to 0. Okay, we are checking for the non-zero elements. Okay, then nums of I comma nums of last non-zero element equal to nums of last non-zero element and nums of I, and our last non-zero element value will be updated with 1. So that's it. It will return the it will push all the zeros to the end of the array. And let me try to run it and check if it works or not. Okay, and we can see here that our code has passed first test case and second test case as well. So now let me try to submit it and check how it performs in terms of time complexity and space complexity. As we can see here that it beats 45% of users in terms of runtime, and it beats around 94.50% of users in terms of memory. So that's it for today's video, and this code solves the problem in big O of n time because we are passing only once through the whole list, and big space is also big O of 1 because it is not using any extra array. If this solution helped you, smash that like button, subscribe and let me know in the comments what problem should we solve next. Until then, thank you for watching and see you in next video.